everyone, so I hope you all are fine. I'm Natasha and welcome back. So today we're gonna continue our chapter 4, and that is motion in a plane. Got it? So basically we're gonna we're gonna simply just discuss about a new topic in our cosine law. This topic comes after cosine law. So what is it? Direction cosines, okay? So what are direction cosines? So let me just tell you in an easy way, and there is a figure given to us, and let me just write something, to understand the main thing, what is mainly, why we do direction cosines, what is direction cosines, why do we use direction cosines, and how can we use direction cosines. Basically, we're going to cover these topics, these things in this topic. Okay, so let's get started. So first of all, let me just write, okay, so as you can see that there are three axes given to us. So actually these are axes. If you're kind of confused in them, these are simply axes. So I've used X, Y, and Z axis. So I'm gonna let these all axes be like these one, okay? So L will be X, M will be Y, and the one more thing is that N will be Z, okay? Got it? Okay, so I hope it is clear to you. And so let's take a question to understand direction cosines. Okay, so first of all, LMN means the x-axis and y-axis and z-axis. Got it? Okay, so we're going to say that, first of all, let me just write the values of these axes. What are they equal to? So I'm talking about that, what will be their values, okay? Just simply we're going to write this. So I'm going to say that L is equal to cos alpha. Here it is given to us, cos alpha, and M is equal to cos beta, okay, which is right here, and the one more is n axis, basically the z axis. So N is equal to cos gamma. Got it? This is gamma, okay? Don't take it as don't take it as y, okay? This is gamma. Got it? Okay, I hope you will not be confused in it, because I've told you. Never mind about that. Okay. So we have to just, prove something in this thing. Let me just tell you what we have to prove. So we just have to simply prove this thing. Wait a second. Okay, so we have to prove that L squared plus M squared plus N squared is equals to 1. Wait, first of all, is this really possible for us or not? Okay, so simply we're just going to find out, is it possible or not? Okay, what do we have to prove? We have to prove that L squared plus M squared plus N squared is equal to 1. Basically their sum will be 1. Okay, so as I told you that these L, M, N are the axes, X, Y, and Z, okay? So first of all, to prove this thing, now I'm going to talk about direction cosines. So, we've used this, we have use this question, I'm just going to solve this question, okay? So before that, let me just tell you what are direction cosines. Just a small definition for that. So direction cosines, basically it is defined as the cosines of the angles. Cosine of the angles between the three coordinate axes. What are the three coordinate axes given to us? That are X, Y, and Z. Got it? Okay, so there are three coordinate axes given to us. So they mainly define the they're mainly defined as the cosines of the angles between the three coordinate axes and what? And the vector. Okay, so one thing you have to always remember, that in a direction cosine you will always need a vector. Okay, if there's not a vector given to us, we're just gonna we're just gonna let that vector be A. Okay, so I'm gonna say vector A. So first of all, let's just draw that vector A. Got it? Okay, so let's just continue. Okay, so here I'm going to write this vector A, or what? A, vector A, got it? And so, first of all, let me just draw the parallelogram. Okay, so, by the parallelogram, we have to find the complement of X. Okay, so, through here we'll write AX, because, these are really common, I've told you many times. And here it will be AY. Here in x-axis AX, y-axis AY, and in z-axis it's going to be AZ. Got it? AZ, AX, and AY. That's it. We have to we have to find out all these things. So we're done with our figure. So let's just solve the question. So direction cosines. Got it? Okay. So first of all, I'm going to write this thing. what is it? So first of all, I'm going to write this in. So cos, just telling you the way how to solve it. This is the simplest way, easiest way, okay? So cos alpha plus cos square alpha plus cos square beta plus cos square gamma. Got it? Okay? So then I'm going to write is equals to what? Is equals to what? They're going to be equal to, oh, there's no more space left. So what I'm just basically going to do, I'm just going to, I'm just going to manage with this place we have, whatever space we have. Okay, so cos square alpha plus cos square beta plus cos square gamma, okay? So it's equals to what? So cos square alpha will be what? A in AX. So I'm going to write AX by A square, because there's squares given to us already. We are just going to use square in all of these, okay? Then plus, okay, so I think we don't need this figure anymore. That was just for the question, to, how it will be in diagram, how it will be in figure form. Got it? So I'm just going to rub this, because for writing the answer, for just solving the question we have right here. And to also understand the topic of direction cosines. So this is it. Okay, so what is going to be cos square beta? Okay, cos square beta will be AY by A, okay? AY by A square plus what? And according to cos square gamma, what was it? AY. Remember? AY and A for all of them. Okay, so AZ upon A square. Got it? This is going to be our first statement, okay? First way, okay? Now, second. So we can also write these things by L, M, and N, okay? So I'm just going to write that L squared plus M squared plus N squared what is equals to what? So they're simply going to they're just simply going to be, I'm going to write it like this way. Okay, let me just tell you. So it's going to be AX by A. So AX squared by A squared. Okay, we're going to write it like this. So now I'm going to use square for both of for both the numerators and denominators. Okay, we have right here. So AX by A square, AX squared by A square. Now AY squared by A square. And now AZ squared by A square. That's it. Okay, you can also put it in a bracket if you want. That's, that doesn't matter. Okay, so now next step will be what? So before continuing on, I'm going to write something, okay? So, those things are, let me just first of all write, then I'm going to tell you what was that about. Okay, so I'm going to make a box right here. Okay, so what if we have to find mod A square, vector, okay? So, vector A square, mod, basically mod. Okay, so what are their values going to be? Tell me, what are their values going to be? This is kind of really easy peasy. Okay, oh, sorry, I used mod in, I'm going to use mod in the next step, okay? So before that, I'll just take it an easy way, so that's why I just removed that mod. Okay, so what is this now? It is A square, only A square without mod. Okay, so A square will be what? And yeah, you can also remove vector if you want to. So, basically, we're going to write it like this way. And also, square will not be included. Okay, let me just take it in an easy way, okay, so that everyone can understand, including me. Okay, so A. First of all, what if we have to find, we have to find the value of vector A. Well, our vector is right here, isn't it? Okay, so what will be the value of vector A? It will be what? AXI cap plus AYJ cap plus AZK cap. This is kind of really common. Now our next step will be what? A square. Got it? A square. Now I'm going to tell you about A square. Got it? Okay, let's just continue. So basically what are going to be its value? It's going to be in under root, okay? AXI cap plus AYJ cap plus AZK cap. Got it? Isn't it? Okay, so next step. Oh, sorry, not an x square. Actually, forgot about it. It's actually a square, but I'm not gonna write square. Okay, we're just simply gonna write what will be the value of this. So this is gonna be mod A, without squares, okay? Because I've, I've rubbed the mods right here. So now I'm going to write them right here, okay? You can even use vector if you want to, but I'm not just going to write it. Okay, so see, it's going to be like this way. Got it? Okay. So now, as I've told you, you can put vector if you want, and I'll just, I'll think about it later, okay? So axik plus ayjk plus azkk. Now our term will be squared. So mod a square will be what? Really kind of confused a little bit, isn't it? Okay, no problem. So we're not getting confused if I'm going to put a vector sign right here, okay? This is kind of helpful for us. Third term is without vector, okay? So that's going to be really easy. Okay, so mod a squared will be what? It is going to be ax squared plus ay squared plus az squared. Got it? That's it. And if I'm going to remove mod, our answer will be exactly same. So a squared will be what? A squared will be ax squared plus ay squared plus az squared. Got it? Oh, I was about to write k cap, but I'm unfortunately not gonna write it. So az squared. Got it? See it again, please. Is it clear to you? Okay, I hope so. It's clear. Now let's just continue. Okay, so we have some important values so that we can just solve the question easily. Got it? Okay, so let's just move on. So what we are, so by x squared and x squared, so you can see their denominators are same, so I'm just going to write them like this way. So L squared plus n squared plus n squared, no need to use bracket. And then I'm going to write what? Ax squared plus ay squared plus az squared. Got it? Oh, this is kind of different. Okay, I'm just going to write them correctly. Okay, so a squared upon what? A squared, that's it. Okay, so now I'm just going to write the really easy way. So L squared plus m squared plus n squared is equals to what? A squared upon a squared. Did you got it? How? If not, then let me just tell you. Okay, so I can see that a squared upon a squared. I used all these things to solve this question, and you can see that ax squared plus ay squared plus az squared is equals to a squared, isn't it? Isn't it? Can you see it? Yeah, it's exactly the same. So can we write a squared? So we can exactly write. There's nothing wrong in it. So if I'm gonna cut now, both values are same. They're x squared and x squared. So I'm just gonna cut them, and what are we gonna get? We're gonna get 1. Yep. This is it. It was too easy. It was kind of really easy. So we have just proved that L squared plus m squared plus n squared is equals to 1. Through these things, okay, that were actually important to find out so that we can just solve the question easily. Okay, without just having confusion. Okay, so now I think now I think I've understood the topic of direction cosines. So let's just move on. So now we're just simply going to take a question, okay, so that we will not have any doubt in our mind that direction cosines are clear to me or not, according to you. Okay, so let's take the question. I'm going to rub the whole board, and then we're going to just write the question. Okay, so I'm going to rub it. So the question is basically going to be, it's basically going to be related to our topic direction cosines, isn't it? So the question is going to be really easy. And okay. Oops. So let's just write the question. Got it? Okay, so let's just continue. And yeah, well, first of all, let me just check the camera. Ooh, it's totally unfocused, no problem. Okay, so let's just see the question. Okay, so question, we're only going to take one question. So question is in what? So I'm going to take a really easy question, that is a vector P. So a vector P makes an angle, what? It makes an angle like what? Okay, so I've written the question in the notebook, okay, so I'm just gonna write it from there, okay. So question is that a vector P makes an angle, and I'll just write that thing. So now an angle alpha, so the angles are alpha and beta and gamma, okay. Oh, this kind of looks like we have to write a B, but it is not a B, it is a beta. Got it? Okay, like theta and beta. Okay, whatever. Okay, so there are three angles given to us that are yeah. So I hope you can understand that why are we doing direction cosines? So basically these are all angles, and we're just finding the cosine of these angles between those three coordinate axes and the vector that's given to us. I haven't written with it. Yeah, vector P. That's it. I forgot to write the, now I'm done. Okay, so now x's are also given to us, and that are x, y, and z. Okay, so a vector P makes an angle alpha, beta, and gamma with the axes x, y, and z. Can you see it? Okay, so let's just move on. Axes respectively. Got it? Axes respectively. So what do we have to do? We have to find the value of what? So there's a thing given to us, and we have to find its value. So what is it? So it is sine square alpha plus sine square beta plus sine square gamma, okay, is equals to what? So you have to find this thing. Got it? So you have to find the value of this thing. Okay? Marker is kind of light, but doesn't matter, okay? I think you can still see that. Yeah, so actually options are also given to us, so that will be really kind of more easy for us. So there are total 4 options given to us, and first one is 1, second one is 2, third one is -2, and fourth one is -1. That's it. Okay, so now let's just solve the question without wasting our time. Got it? Okay, so first of all, I think you have, you not forgot that in the last topic, we just solved the question that L squared plus N squared equals to 1. And so as you can see that cos, so the sum of the 3 cosine of the angle, okay? Okay, so cos is for, I think cos is for cosine, is it? It is actually. Sine means sine, sine, and cos is mainly for, I think, so cos is mainly for like cosine. I'm not sure, but it doesn't matter. So but yeah, still we're gonna say it's cos, not cosine, okay? Okay, so cos square alpha plus cos square beta plus cos square gamma is equals to 1. So for finding sine, for finding this exact value in sine, what we have to do, we need to know, first of all, we need to know the cos. Okay, for that exact thing we have to find. Okay, so there's cos square alpha plus cos square beta plus cos square gamma is equals to 1 too. Okay, always remember it. Okay. So to find the value of sine square alpha plus sine square beta plus sine square gamma, what are we just simply gonna do? We're just we're just gonna subtract 1 from all of these angles. Got it? So because it is in cos, and if we're gonna subtract it in sine square, then that's how we can get our answer. Got it? Okay, so what I'm gonna write 1 minus. Oh, sorry. Yeah. 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma. Got it? Got it? Okay, so this is it, and it equals to what? 1, okay? So it's like really easy peasy, okay? So now what are we gonna get? So first of all, what do we have to do? We're just gonna shift sine square alpha and sine square beta, sine square alpha, sine square beta, and sine square gamma on right hand side, okay? And 1 will be on left hand side. Got it? So what will be here? What do we have left? So what's left? So 1 plus 1 plus 1 is left, and in the right hand side, what do we have? 1 minus will be in positive, so positive sine alpha plus sine square beta plus, okay, I'm just gonna write it again, okay? No problem. Sine square beta plus sine square what? Gamma. Got it? Okay, I'm gonna just write it again. Okay? Okay, so now what are we gonna do? So after solving this, we're gonna get 3 and now shifting 1. So 3 minus 1, you know, like its sign's gonna be changed. It's in positive, it's gonna be negative. And what's left? So sine square alpha plus sine square beta plus sine plus, oh my gosh, sine square gamma. Got it? Okay, so 3 minus 1 will be equal to 2. That's it. And we find out a value of sine square gamma plus sine square beta plus sine square gamma. Got it? I think so. Sine square gamma. Got it? Okay. Okay, so that's it. And 2 is our answer. Let's find it out. Is it in an option? Oh yeah, 2 is actually in the option. That is option B. 2 is our answer, and that's how we just solved this question really easily. Isn't it too easy? So we just, we've just done direction cosines topic, and that's it. We're done with our topic of direction cosines. And yeah, one more thing I have to tell you that wasn't really easy question, so that, we can understand that what is mainly direction cosines about. So, but next time we're going to take some difficult questions on this same topic, but any other time, okay? So in the next video, we're just simply going to continue in volume of a parallelepiped that is in this exact same chapter, and else we will do any other topic, okay? I don't know what we're going to do next topic, but next video, but that's all for today, and thanks for watching and have a great day.